Next example, on the variable separable form, y dash is equal to minus 2x, y square minus 3y plus 2, y0 is equal to 3. That is why I have to find the particular solution. First, we have to find the general solution. So y dash is what? dy by dx is equal to minus 2x in bracket y square minus 3y minus 2. Then we have to separate first the variables. So shift this bracket to LHS, it become divided by, shift this dx to RHS. And so it is now it is in the variable separable form. And so now integrating both sides, we have this, add the constant of integration, suppose C1 is the constant of integration. Now we have to find the integration of this factor 1 divided by y square minus 3y plus 2. Obviously, it is by using integration by using partial fractions. So we have to find the partial fractions of y square minus 1 by y square minus 3y plus 2. So what are the factors of y square minus 3y minus plus 2? Is y minus 1, y minus 2. And then is equal to a divided by y minus 1 plus b divided by y minus 2. Then y minus 1, y minus 2 as LCM. So a into y minus 2, b into y minus 1. Then substitute. Then we have the equation 1 is equal to a into y minus 2 plus b into y minus 1. This is equation suppose star. Then put y is equal to 1, y minus 1, y minus 1 is equal to 0. It gives y is equal to 1. So substitute y is equal to 1. And then y minus 2 is equal to 0 gives y is equal to 2. Substitute y is equal to substitute y is equal to 1. We have LHS is 1 and RHS is a. 1 minus 2 is minus 1 and 1 minus 1 0. The coefficient of b is 0. And therefore a is minus 1. And substitute y is 2. So the coefficient of a becomes 0 and the coefficient of b is 1. And so b is equal to 1. And therefore the factorization of partial fractions of this 1 divided by y square minus 3y plus 2 is what? Are what? Minus 1, a is minus 1 by y minus 1 plus b is 1 by y minus 2. So these are the partial fractions of this quantity. Substitute the value of this quantity here at this place. We have integration 1 minus 1 by y minus 1 plus y minus 2 dy is equal to integration minus integration 2x dx plus c1. And then integration of 1 by y minus 1 is log y minus 1. And 1 by y minus 1 is what? Y minus 2 is what? Log y minus 2 is equal to 2x x square by 2. So minus x square plus c1. And then log a minus log b is log a by b. So log y minus 2 divided by y minus 1 minus x square plus c1. And so y minus 2 divided by y minus 1 is equal to e raised to minus x square c1. If you shift the log to its inverse is exponential function. So log a is b, then a is e raised to b. So log y minus 2 divided by y minus 1 is e raised to minus x square plus c1. So e raised to minus x square into e raised to c1 by factorization. So base and then power, addition of power. And suppose this e raised to c1 as c. Suppose this e raised to c1 as c. So what we have? We have y minus 2 divided by y minus 1 is equal to this e raised to c1 as c e raised to minus x square. And this is the general solution of the given differential equation. This is the general solution of the given differential equation. Now we have to find the particular solution. And what is given? Condition is y0 is equal to 3. So what is the meaning of y0 is equal to 3? Means y is 3 if x is 0. So substitute y as 0, y as 3 and x as 0 in this condition. So y0 is equal to 3 means y is 3 if x is 0. So put y is equal to 3 and x is equal to 0 in the general solution. What we have? 3 minus 2 divided by 3 minus 1 is equal to c into e raised to 0 because x is 0 and e raised to 0 is 1. So this is 1 half and c is 1 half. So substitute c as 1 half in this general solution. So we have y minus 2 divided by y minus 1 is equal to 1 half e raised to minus x square. And this is the required particular solution. That is the solution with the initial condition y0 is equal to 3. So this problem, all these problems are of the variable separable form. If we observe this problem, then it is also of the same type, that is by using integration is by using partial fractions. So in all these problems are of the type first, that is variable separable, that is separate the variables and integrate. So these are the some problems for homework for assignment. So write all the answer of all the problems in the assignment notebook. Just separate the variables and integrate. Just separate the variables and integrate. So write y dash as dy by dx. If you observe this problem, then it becomes 1 divided by y plus 1, y minus 1, y minus 2 dy is equal to 1 by is equal to minus 1 by x plus 1 dx. And we have to integrate this 1 divided by y plus 1, y minus 1, y minus 2 by using partial fractions. That is, we have to first obtain the partial fractions like this. That is, what are the factors? Partial fractions: a by y plus 1 plus b by y minus 1 plus c by y minus 2. Then find the values of a, b, c. So the integration here by using partial fractions. So here y square plus 1, y into y square plus 1, again using by using partial fractions. So solve all these problems. Y square minus 3y plus 2, then again by using partial fractions. So solve all these examples. Some more examples on variable separable. See this example: y minus x dy by dx is equal to a y square plus dy by dx. So we have, this is the example we have after separating, that is, shift this quantity minus x dy by dx to RHS. So it is a dy by dx plus x dy by dx, and substitute, shift this a y square to LHS. So y minus a y square. Then take dy by dx as common, and then separate the variables. So dx divided by shift this dx to LHS, x plus a to LHS. So it is become 1 by x plus a into dx, and this becomes dy 1 by y minus a y square dy. So this is now in the variable separable form. So after separating the variable, we have this. Then integrating both sides. So add constant c1 as the constant of integration. And then 1 by x plus a, integration is log x plus a. But if we have to integrate this 1 divided by y minus a y square, we have to obtain its partial fractions. So integration is by using partial fractions. So y into 1 minus a y, these are the two factors. And then write a by y plus b by 1 minus ay, and then obtain the value of a and b. What are that? 1 and a are the values of a and b. So here we obtain first the partial fractions of this 1 divided by y into 1 minus ay by using this method. That is, write a divided by using this method like this: a divided by the first factor plus b divided by the second factor, and then find the values of a and b. So we have the partial fractions of this 1 divided by y into 1 minus ay as 1 by y plus a divided by 1 minus ay dy plus constant of by partial fractions. And then integration of 1 by y is log y, and 1 by a minus 1 minus ay is log 1 minus ay divided by y, divided by a, because divided by a and into one this a, so which becomes it becomes 1. So 1 a as it is, right? A as it is, and then the integration of 1 by 1 minus ay by using the rule 1 by ax plus b. What is the integration of 1 by ax plus b? Log ax plus b divided by a. So here divided by minus a, and so a divided by minus a becomes minus 1 sign, minus sign, log 1 minus ay. So don't write this step directly from this step. Here write a first, write it here a. This a is at this place, and then 1 by a minus y, integration is log 1 minus ay divided by minus a, and this a divided by minus a becomes minus 1 in the next step, plus constant of integration, suppose log c1 or c1, where c1 as log c. Okay, and then log x plus a is equal to log y minus log 1 minus ay plus log c. So suppose c1 as log c, c1 as log c, so right here log c, and then we use the rule of log a minus log b. Shift these two quantities to LHS, this become minus and this become plus. And then use the rule log a plus log b is log a into b, and log a minus log b is log a by b. So we have log x plus a into 1 minus ay divided by y is equal to log c. Cancel the log of both sides. So x plus a into 1 minus ay divided by y is equal to c. And then cancel the log of both sides. And then we have x plus a into 1 minus ay is equal to cy is the required solution. So this is again the example of variable separable. Separate the variables and integrate. Next example, dy by dx is equal to e raised to x minus y plus x square e raised to minus y. So e raised to x minus y means e raised to x into e raised to minus y. X square e raised to minus 1. Take e raised to minus y as common. So we have e raised to x plus x square, and then separate the variables. So e raised to minus y, after shifting to LHS, it's become 1 by e raised to minus y means into e raised to y dy is equal to x square plus e raised to x dx. So now it is in the variable separable form. Integrating both sides, we get integration of e raised to y, integration of this plus constant of integration, suppose c. Then e raised to y, integration e raised to y. And then x square integration x cube by 3 plus e raised to x integration itself e raised to x plus constant. And this is the required general solution of the given differential equation. Next example, log dy by dx is equal to a plus b y. So taking antilog of both sides, or shift this log to LHS. And so we have dy by dx is equal to e raised to ax plus by, because if log a is b, then a is e raised to b. So we have then separate e raised to ax into e raised to by, and then e raised to x into e raised to by, dy by dx is this. Separate the value. So see, so this e raised to by to LHS, it becomes e raised to minus by dy is equal to e raised to x, shift this dx. So now it is in the variable separable form. And then we have to integrate both sides. So what we have? We have this e raised to minus by integration e raised to minus by divided by minus b. And then integration of e raised to x is e raised to x divided by a, derivative of ax, plus constant of integration. So it is b e raised to x, that is throw divided by multiply by ab. So b e raised to x plus a e raised to minus by is equal to constant of integration, suppose k is what, minus abc, that multiply by minus ab to throw, we have this answer. Okay, so this is the general solution or required solution of the given differential equation. So again, this is the example of variable separable form, type 1. Then next example, solve cos x cos y dy plus sin x sin y dy is equal to 0. Now we have to separate the variables. So multiplying by sin y cos y, dividing by sin y cos y, sin y cos y, dividing by so what we have, cos y divided by sin y divided by cos x into cos y, cos x into sin y divided by cos x into sin y. So or shift this quantity to RHS, and then shift the sin y to LHS and cos x to RHS. We have this. Okay, we have cos y divided by sin y dy is equal to minus sin x cos x dx. So this is in the variable separable form, integrating. And cos y by sin y is log sin y by using the rule f dash x divided by fx. Derivative of sin y is cos y. So by using the rule f dash x divided by fx, it is log sin y, or cos y by sin y is cot y, and integration of cot y is log sin y, and integration of sin x by cos x is tan x, and integration of tan x is log sec x is equal to, suppose, log c as constant of integration. Then log a plus log b is log a into b, and then cancel the log of both sides. We have sin y into sec x is equal to constant, and this is the required solution of this differential equation. Next example of the variable separable form, 1 plus e raised to 2x dy plus 1 plus y square e raised to x dx is equal to 0. So it's being given that y is 1 when x is 0. That is, we are given the condition, initial condition, y 0 is equal to 1. Y is 1 and x is 0. So first we have to find the general solution. 1 plus e raised to 2x dy plus 1 plus y square e raised to x dx is equal to 0. So separate the variables. What do we get? We get dy shift this quantity to RHS and then separate the variables, or directly we have dy divided by 1 plus y square dx divided by 1 1 plus e raised to 2x dx is equal to 0. Okay, that is shift this quantity to RHS and then it's become minus, and then shift the quantity. We have this. Then integrating both sides. What we have? So integration dy divided by 1 plus y square integration e raised to x 1 plus e raised to 2x dx is equal to constant of integration, and this 1 by 1 plus y square is integration is tan inverse y, because derivative of tan inverse y is 1 by 1 plus y square, and integration of this quantity is by using substitution, integration by substitution. Substitute e raised to x as t, and then e raised to x dx is dt. So e raised to x dx is dt 1 by 1 plus e raised to 2x means e raised to x bracket square, when e raised to x is t, so it is t square is equal to constant, and the integration of 1 by 1 plus t square is tan inverse t, and then substitute t as e raised to x in the next step. So tan inverse y plus tan inverse e raised to x is equal to constant is the general solution of the given differential equation. Now we have to find the particular solution. So substitute y is 1 and x is 0. We get in this equation, general equation, we get tan inverse 1 plus tan inverse e raised to 0 is equal to constant. And tan inverse 1 plus tan inverse e raised to 0 is 1 is equal to c, and tan inverse 1 is pi by 4. So pi by 4 plus pi by 4 becomes pi by 2, and so c is pi by 2. Substitute this value in the general solution, this equation. So we have tan inverse y plus tan inverse e raised to x is equal to pi by 2. It is the required solution of required particular solution of this differential equation. So these are some problems on the order and degree of the differential equation. So these problems are important as far as the MCQ type questions. It's an MCQ type examination. That is, find order of the differential equation, find the degree of the differential equation. So dy by dx bracket square plus 5y is equal to sin x. So this is the differential equation of order 1, because dy by dx is of order 1, and order power of the highest order derivative. Highest order derivative is dy by dx. Its power is 2. So degree is 2. Order is 1, degree is 2. If you observe this, order is 2 and degree is 3, not 4, because we have to find the power or index of highest order derivative. So it is dy by dx is not highest order derivative. This d square y by dx square is the highest order derivative, and its power is 3. So its order is 3. Order is 2 and degree is 3. Similarly, this is the example. Obviously, dy by dx is the term. So order and degree both are 1. And now we have to squaring this sides. Square both sides, because p is dy by dx. So squaring the both sides and then find the order and degree, because it is not free from radical signs. We know that the definition of order and degree of the differential equation. When we can find the order and degree of the differential equation, if the differential equation is free from radical signs and free from fractional as far as the derivative concerned. So we have to remove this sign, root sign. So in order to remove this root sign, we shift this px to LHS. So y minus px is equal to plus minus c root p square plus 1, then squaring both sides, and then find the, similarly here squaring both sides. So we have d square y by dx square bracket square is equal to 1 plus dy by dx square, and then find the order and degree. Similarly this example. So answer of this is given, answer of order and degree of each example. So dy by dx is equal to this order, and that is the simplification of this third example. The simplification, it is in the form dy by dx. It is dy by dx is equal to x cube minus y cube divided by this. So order is 1, degree is 1. So we have to shift this by px to LHS and then squaring both sides. So we have y minus px bracket square is equal to c square in bracket p square plus 1, and then find order and degree. So order is 1 and degree is 2, because p means dy by dx bracket square. So our degree is 2. Similarly, The next example, order and degree. Order is 2, degree is 2. The next example, order is 2 and degree is 2. Observe this example. This example. So squaring both sides. First squaring both sides. So d square y by dx square bracket square is equal to this. And then d square y by dx square, highest order derivative is of order 2, and d square y by dx square bracket square is there. So degree and order both are 2. Degree and order of both are 2. Then next example, the last one. Degree is not defined. Order is 2, and degree is not defined. The last example. The highest order of derivative is d square y by dx square, but we cannot define the degree of this differential equation because it is in the cos dy by dx. This is not actually the general form of the differential equation. So we can write order, but we cannot write the degree of the differential equation. Then example, find the differential equation of family of all straight lines making equal intercept on the coordinate axis. So, what is the equation? The general equation of family of all straight lines making equal intercept C on the axis is this: x by c plus y by c is equal to 1. That is x plus y is equal to c. This is the general equation of the line making equal intercept C on the axis. So what is the general form of the equation of straight line in the intercept form? X by a plus y by b is equal to 1. So its makes intercept C on x-axis and y-axis. So its equation is x by c plus y by c is equal to 1. That is x plus y is equal to c. And now we have to eliminate this c in order to obtain its corresponding differential equation. So these are the problems of, so differentiate. What do we have? X derivative is what? Plus dy by dx is equal to 0. And this is the answer. Because uh, this equation contains only one constant and we have to eliminate that. So these are the examples on the formation of differential equation. These are the examples on the formation of differential equation. So already some examples of these types are solved by solved in the previous lectures. So we will solve these 6, 7, 8, 9, 10 and all these examples in the next lecture.